All right, so we're going to review for your conceptual unit 3 test. There's a lot of questions, but a lot of them are going to go really fast. A lot of them are just vocabulary. In the rectangular coordinate system, the horizontal number line is called and again, the answers are on here. It was easier for me to do that than to try and go through every part and pick it. Anyway, when you have a rectangular coordinate system, they're talking about a graph. Okay, this axis, the horizontal axis, is called the x-axis. The vertical axis is called the y-axis. And if you have a point, they're giving you the example 2, 1. The first number is called the x-coordinate. Remember, every ordered pair goes x comma y. So the first 2 would be called the x-coordinate, and 1 would be called the y-coordinate. Find 7 ordered pairs to this equation, then determine its graph. And again, they've already got the answers here, but how they got them was they plugged in each of these x's and solved for y. So to get 7, they said y equals negative 3 squared minus 2. Negative 3 squared is positive 9, minus 2 is 7. To get the next one, y equals negative 2 squared minus 2. That's 4 minus 2, which is 2. Y equals negative 1 squared minus 2. That's 1 minus 2 is negative 1. Y equals 0 squared minus 2 would be 0 minus 2, which would be negative 2. Y equals 1 squared minus 2 would be 1 minus 2 would be negative 1. Y equals 2 squared minus 2 would be 4 minus 2 would be 2. And y equals 3 squared minus 2 would be 9 minus 2 would be 7. That's how they got all of these numbers. And then if you plot them, if you graph them, negative 3, this is a really bad graph because they're counting by 2s, and so it's really hard to tell. Okay, so if I plot this ordered pair would be negative 3, 7, negative 3, 1, 2, 3, 4, 5, 6, 7, negative 2, 2, negative 1, negative 1, 0, negative 2, 1, negative 1, 2, 2, 3, 7. And if we connect those, there's my parabola. Okay, this one the same thing, but now our function is absolute value. So again, to find the y's, you substitute these x's in. So I have y equals negative 3, absolute value negative 3, which would be negative 3 times 3, which would be negative 9. Y equals negative 3 times the absolute value of negative 2 would be negative 3 times 2 would be negative 6. Y equals negative 3 times the absolute value of negative 1 would be negative 3 times 1, which would be negative 3. Y equals negative 3, absolute value of 0 equals negative 3 times 0, which is 0. Y equals negative 3 times the absolute value of 1 is negative 3 times 1 is negative 3. Y equals negative 3 times the absolute value of 2 would be negative 3 times 2 is negative 6. And y equals negative 3 times the absolute value of 3 would be negative 3 times 3 would be negative 9. That's how they got all their y's. If they graph it, negative 3, negative 9, negative 2, negative 6, negative 1, negative 3, 0, 0, 1, negative 3, 2, negative 6, 3, negative 9. And if you connect the dots, pretend that they line up there. Okay, that would be your V shape. Alright, use the graph to the right to complete the following. For the graph, tick marks along the axis represent 1 unit each. Determine the X intercepts. X intercepts are where it crosses the X axis. So right there is my X intercept. And the coordinates of that point would be 1, 2, 3, comma, 0. But they don't want the whole ordered pair, they just want an integer, so they want the x coordinate. Okay? B, they want the y-intercept. The y-intercept is where it crosses the y-axis, so that would be my y-intercept right there. Its ordered pair would be 0, comma, 5. Sorry. Alright, so the y-intercept is, the y-coordinate only, is 5. Okay, use the graph, and A, determine the x-intercepts, if any, and B, determine the y-intercepts, if any. Well, there's my x-intercept. Its coordinates would be at 1, 0. So my x-intercept is 1. And you can see it doesn't cross the y-axis at all, so there are no y-intercepts. Okay, select the answers that best complete the given statements. A set of ordered pairs is called a relation. The set of all first components is called the domain, and the set of all second components is called the range. Okay, in other words, the x's are the domain values, the y's are the range values. Okay, fill in the blanks so that the resulting statement is true. It says if any vertical line intersects a graph more than once, then the graph does not define y as a function. They're talking about the vertical line test. If I have a graph and I don't know, let's say I have a parabola. If it passes the vertical line test, meaning every vertical line I draw only intersects the blue one time, then it's a function. If you get something that crosses it more than once, like for example, let's say I have a graph of I don't know, how about a sideways absolute value function? This would not be a function because I can find a vertical line that touches it in more than one spot. So if any vertical line intersects a graph more than once, then it is not a function. Okay, that's the vertical line test. Determine whether the following relation represents a function. Remember your definition. This is a relation because it's a set of ordered pairs. To be a function, all x's must be different. Okay, the -2, 0, 8, and 1. They're all different, so yes, it's a function. If it's a function, then they want the domain and the range. Well, the domain is all of the x's, so -2, 0, 8, and 1. The range is all of the y coordinates. -3, 1, 8, and 1. And notice they don't have to list the 1 twice. You can, but you don't have to. Okay, determine whether the following equation defines y as a function of x. Look at your degrees. If x has a degree higher than 1, a 2, a 3, a 4, a 5, and y has an exponent of 1, then I promise it's going to be a function. So if I look at my exponent of x, it's a 1 and y is 1. That means it's going to be a function. The other way you can tell is think about the shape of it. First degree are lines. Lines pass vertical line tests except for the vertical line. So it's a function. Okay? Determine whether the following equation defines a function of x. If you go with my exponent rules, you can have a high exponent on 2, but y has to have an exponent of 1. So yes, it's a function. Again, the other way is you know the shape of this. X is squared means it's going to be a parabola that either opens up or down. This one's going to open up because it's positive. That will pass a vertical line test. So yes, it's a function. And then on the bottom one, remember I told you if both letters are squared, you're going to have a circle or an ellipse or something. That will not pass a vertical line test. So no, that is not a function. Okay. All right, it says evaluate the function at the given values of the independent variable and simplify. They're telling me to find, here's my function, f of any x you plug in, says take the x, multiply it by 2, and subtract 5. For A, they want me to find f of 9. So to find f of 9, I'm going to replace the x in my function with 9. I'm going to replace x with 9. You don't do any math over here. That's just function notation. F of 9 equals 18 minus 5. So f of 9 equals 13. Okay? For b, they want me to find f of x plus 8. Notice how I copy my function, but I leave the x's out, and I'm going to replace them with what they tell me to, which is x plus 8. So everywhere I see an x, I put x plus 8 instead. And then when I simplify, don't do any math on this side. That's just function notation. F of x plus 8 is going to be 2x plus 16 minus 5. Combine like terms. That gives me 2x plus 11. Okay? And then third, they want me to find f of negative x. So I'm going to take my function, but instead of x, I left holes. And now I'm going to plug in negative x and simplify. Again, you don't do anything on this side. That's just function notation. F of negative x is going to equal, distribute, negative 2x minus 5. And I can't simplify it anymore, so there's my answer. All right, do it again. Here's my function now. F of x equals x squared minus 4x plus 3. For a, they want me to plug in negative 1. Everywhere I see an x, everywhere there was an x, I replace it with negative 1. No math on this side. Negative 1 squared is positive 1. Negative 4 times negative 1 is positive 4 plus 3. 1 plus 4 is 5 plus 3 is 8. Okay, there's A. For B, again, my function f of x equals x squared minus 4 times x plus 3. But this time they want me to plug in x plus 5. Everywhere there was an x, I change it to x plus 5. Okay, and when we simplify now, to square a bino without killing puppies, we're going to have to make 2 copies. So this is going to be x plus 5 times x plus 5. I can go ahead and distribute there. That's going to be negative 4x minus 20 plus 3. Keep simplifying. I've got to distribute. That's x squared plus 5x plus 5x plus 25 minus 4x. And I'm going to go ahead and combine these right now, minus 17. Now combine like terms and clean everything up. I've got an x squared. 5x and 5x is 10x. Minus 4x is 6x. And 25 minus 17 is 8. So f of x plus 5 equals x squared plus 6x plus 8. And then the last one they want me to find is f of x equals x squared minus 4x plus 3. But now they want me to plug in a negative x. No math on this side, where this just drops. Negative x squared is positive x squared. Negative 4 times negative x is positive 4x. Bring down the positive 3. There's no like terms, so for C I am done. Okay. Alright, use the vertical line test to determine if y is a function of x. If it passes the vertical line test, it is. If it does not pass the vertical line test, it is not. Not a function, because it doesn't pass the vertical line test. Okay, use the graph of g to find g of 4. When they're telling me to find g of 4, they're telling me to locate the ordered pair that has 4 for an x coordinate. Well, there's 4. If I go to the graph, the y coordinate that goes with that is negative 9. So g of 4 is negative 9. You're just finding the missing piece of the ordered pair. Now, this one says g of x equals -6. So you're trying to find the ordered pair that has a y coordinate now of -6. So if I go to -6 on the y and I go over to my graph, there's the point that corresponds to a y coordinate of -6. Read its exponent, and it is 4. Okay? Use the graph to determine A, the function's domain, B, the function's range, C, the x-intercepts, and D, the y-intercept, and E, the missing function values, indicated by the question marks below. Alright, domain. If you try and block this right to left, it's going to break on through to the other sides, which means my domain is -infinity to infinity. For range, block it at the top and the bottom. It's going to break through on the bottom, so that means my range starts at -infinity, but it stops right here. And the highest that goes is 1, 2, 3, 4. Okay, so it stops at 4. There's my range. X-intercepts. To get the x-intercepts, you look and see where it crosses the x-axis at. It's crossing right there, which is at 1, 2, 3, 0. And right here, which is at -1, 0. So my x-intercepts are -1 and 3. The y-intercept is where it crosses the y-axis at, which is right there, which is at 1, 2, 3, 0, 3. Okay, which means my y-intercept is 3. And then to find these two functions, to find f of -2, they want me to find the ordered pair that has -2 for an x-coordinate. So if I go to -2 on the x-axis, -2 is right there, go down to the graph, its y-coordinate is -5. To find f of 2, again, they're wanting an ordered pair where 2 is my x-coordinate. So if I go to 2, go up to the graph, read over to the y, that's at +3. Okay? Alright, did I skip one? Yes, I did. Okay, we did that one. Alright, use the graph to determine the following. The function's domain. The domain, I can block it now. You see how it's not going to go past, it's not going to go any farther this way. So the domain starts at 0, and it includes it, because this is a filled in. You're going, but miss, that's at -4. Yeah, but I'm on domain. Domain, you're looking at x-coordinates. And this function goes from this x-coordinate to this x-coordinate. Everything in between is the domain of my function. Well, that stops at 1, 2, 3. That circle is at 3. So it stops at 3. And that circle is open, so 3 is not included. There's my domain. Okay? My range is bottom to top. There's the bottom. There's the top. My range is everything in between here. So my range starts at -5 and -4 and includes it because that circle's filled in, and it won't go past 5, and that one's open, so it is not included. So there's your domain and your range. The x-intercept, you're looking for where it crosses the x-axis, and it crosses at 2, 0. Again, they're just using the x-coordinate. The y-intercept, it's crossing, or it touches the y-axis right there, which is at -4. That ordered pair is 0, -4. But again, for the y-intercept, you only take the y-coordinate. And then they want me to find the value of f of 1. Well, to find the value of f of 1, I'm looking for an ordered pair that has an x-coordinate of 1. If I go to my graph, there's 1, go down on the graph, read over to the y-axis, and that is at -3. Okay? Alright, fill in the blank so that the resulting statement is true. An equation that can be written in the general form ax squared plus bx plus c, as long as a is not 0, is called a quadratic. Second degree means quadratic. The zero product principle states that if AB equals 0, then either, remember the product property? This was like if you had this, then you could say either this was 0 or this was 0. So if they're saying AB equals 0, then it states that either A is 0 or the other thing being multiplied is 0. There's only one way to get 0 from multiplying, and something has to be 0. Okay, 24, fill in the blank so that the resulting statement is true. The solutions of a quadratic equation in standard form, ax squared plus bx plus c equals 0, as long as a doesn't equal 0, are given by the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Okay, fill in the blank so the resulting statement is true. In order to solve 6x squared plus 7x minus 1 equals 0 by the quadratic formula, use a, b, and c. They want me to identify a, b, and c. A is whatever touches the squared term. B is whatever touches the linear term. And c is the constant. Okay, select the correct choice. The discriminant of a quadratic is defined as b squared minus 4ac. It's the part that goes under, not the whole thing. It's not the square root of it that's my discriminant. It's just the discriminant. Okay. If the discriminant is negative, then the quadratic has no real solutions. It means it has 2 imaginary solutions, which means the function will not cross the x-axis. Okay? If the discriminant is positive, then you're going to have 2 real solutions, meaning the parabola will cross the x-axis twice. Okay? And if it's this one, the other one's not on here, I'm not really sure why, but if it's exactly 0, then there's only 1 solution. Alright, solve by factoring. When a is 1, I absolutely love to factor because it's not hard. Factors of x squared that can multiply together to make x squared are x and x. Factors of 10, meaning 2 numbers that multiply to make 10 but add or subtract to make 9. Well, it would be 10 and 1. Ooh, no. My bad. This is not in proper form. To solve by factoring, you have to have 0 on one side. So I actually need to rewrite this. This is going to be x squared minus 9x minus 10. And the way I got that is I subtracted 9x from both sides. That gives me x squared minus 9x equals 10. Then I minus 10, oops. Then I'm sorry, come up here. Oops. Darn it. Let me get my pen back. So I have x squared minus 9x equals 10 minus 10 minus 10. I get x squared minus 9x minus 10 equals 0. Okay, now, again, it still should be pretty easy to factor. I just had my signs messed up because they weren't all on the same side. Factors of 10 that make 9 are 10 and 9. C is negative, so only the bully, the biggest number, gets the middle sign. So 10 gets the negative and 9 has to be positive. And now we can use the zero product property to solve. I'm saying this multiplied by this equals 0, so then either x minus 10 equals 0 or x plus 9 equals 0. Add 10, you get x equals 10. Minus 9, you get x equals negative 9. I'm sorry, 10 and 1, not 10 and 9. Ooh. So x equals negative 1. I'm so sorry, I don't know what I was thinking. Okay. Alright, solve this one by factoring. To do this one, you're going to have to do a times c. Find all the factors. Rewrite b, 2 by 2, GCF again. Hold on just a second. So I hit, and I'm back. had to get a calculator. All right, so to solve this by factoring, we have to do the whole song. We have to do A times C, rewrite B, 2 by 2, GCF, GCF, GCF again. Woo! So A times C, that would be 9 times 8 would be 72. I need all the factors of 72. 1 and 72 will not make, I'm trying to make 21 in the middle. 2 goes into 72 36 times. That's not going to make 21. 3 goes into 72 24 times. And that will make my 21. So now I have to rewrite B. And that's how I'm going to do it. I'm going to do it with a 3x and a 24x. So I'm going to rewrite this. I'm going to keep my 9x squared. My minus 8 equals 0. But I'm going to rewrite my 21x as 3x and 24x. I just have to figure out the signs. If C is positive, they both get the middle. If C is negative, only the bully does. C is negative, so bully 24 gets to be just like the middle, which in this case was positive, which means 3x has to be negative. And notice, if I take negative 3 plus 24, I still have positive 21x's in the middle. So I did A times C, I found all the factors, rewrote B, now I'm at 2 by 2, and you literally split it, 2 terms on one side of the wall, 2 terms on the other. Now you're going to GCF on the right. What can I factor out? They have a 3 and an x in common. If I divide by 3x, I get 3x, and divide by 3x, I get negative 1. On the other side, I'm going to GCF, and they have an 8 that will go into both of them, but I'm always going to take the first sign, so I'm going to divide by positive 8. 24x divided by 8 is 3x. Negative 8 divided by positive 8 is negative 1. So there's GCF, GCF. Your GCF again comes from the matching bino that is now always going to be on both sides. If you don't have a matching bino at this point, either you did something wrong or it's prime. So my GCF again, sorry, let me change my color here. My GCF again is the matching bino, 3x minus 1. And the purple and the blue, the GCFs, make up your second bino, equals 0. Now, to solve, to turn these factors into solutions, you set them to 0 and solve. Add 1, I get 3x equals 1. Divide by 3, x equals 1/3. Minus 8, 3x equals negative 8. Divide by 3, and I get x equals negative 8/3. Okay. Use factoring to solve the quadratic equation. Check by substitution or using a graphing utility and identifying the x intercepts. All right, for this one, there aren't 3 terms. I still can't do square root property because I have a first degree x. The only time square root property works is when you only have a squared x. When there's 2 terms, I don't have to do the whole A times C song. I can just GCF times what's left. And these guys have a 2 in common and an x. If I factor out a 2x, that's going to leave me x plus 5 equals 0. So now my factors, to turn my 2 factors into zeros, I take 2x, set it to 0, and x plus 5 and set it to 0. To get x alone on the first one, divide by 2, I get x equals 0. To get the second one, minus 5, x equals negative 5. So my solution set is 0 and negative 5. Okay, solve the equation by the square root property. If they use the language square root property, they're telling you to isolate and kill whatever's being squared. So since I have 3 parentheses x plus 6 squared equals 36, I can't square root until I get rid of, in other words, to kill this square, I've got to square root, but I can't do that until there's nothing left on the outside of the walls. So to get rid of multiplying by 3, I'm going to divide both sides by 3. That gives me x plus 6 squared equals 12. Now it's isolated, so I can kill it by taking the square root of it, which gives me x plus 6. And they don't want decimals, they want radicals, so I just need to break down 12. By 2 is 6, by 2 is 3. 2 2's make a perfect square 2. 3 has to stay in. So x plus 6 equals plus or minus 2 square roots of 3. And then one last thing, to get x alone, I have to subtract 6. And that kills it and gets my x alone, yeah. I can't combine those because he has a radical and he doesn't. So the best I can do is negative 6 plus 2 square roots of 3 and negative 6 minus 2 square roots of 3. Okay? Determine the constant that should be added to the binomial so that it becomes a perfect square. It's always going to be half of b squared. That's always what's going to make it perfect. Okay? So in this case, my b is 16. Half of that would be half of 16 would be 8. Square that, and it'd be 64. To write the trinomial, you take these two terms, two terms they gave you, and you add on, if it's positive, or subtract from the polynomial your half, adding the half of b squared. You just add whatever you found up here. And that's writing the trinomial. Then they want you to factor it. Well, you just spent all that time to make it a factorable polynomial. A perfect one at that. So it's going to be Bino squared. To get the terms, you take the square root of the n's. The square root of x squared is x. The square root of 64 is 8. And I promise the sign will always be what's in the middle. Okay? Alright, give me just a second again. Okay. Alright, solve by completing the square. The first thing you do is you move this constant to the other side, which will give me x squared plus 8x equals negative 2. Okay, to complete the square, you always add half of b squared to both sides. That's what will complete the square. So my b is 8. Half of that is 4. Half of that squared is 16. So what I need to add is 16 to both sides. Everything else is going to stay the same. So I have x squared plus 8x equals negative 2. I just added 16 to both sides. Once you do that, this side is ready to factor, and it's going to be a perfect square with the square root of x squared, the sign in the middle, and the square root of the end, which is 4. On the other side, PEMDAS, simplify, which is 14. Then to solve, you need to get x alone. Well, kill the square root. That gives me x plus 4 equals plus or minus the square root of 14. I can try and break it down, but by 2 is 7, there's not 2 of anything. So I'm done. I can't break it down. I don't need those parentheses anymore. All I have left to do is to get x alone, so I'm going to minus 4 from both sides. And you can't subtract a radical from a whole number without going decimal. So my two solutions are negative 4 plus or minus the square root of 14. Again, they make you write it out, both of them separately. All right. Solve the following equation by using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this problem, A is 2, B is -3, C is -1. So if I take my quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a, and I promise guys, you're writing it anyway. Why not write it ahead of time, and then you know where to put things without messing up signs. Okay, b goes here and here, a goes here and on the bottom, and c goes on the very end. So now if I clean this up, I have x equals, distribute as a +3, plus or minus. Here, I would just type it in a calculator, but if you're going to use your brain, that's going to be 9 plus 8, because this negative times this negative is going to make it positive. And that gives me 17 all over 4. And again, the only thing you would be able to do at this point, if anything, would be to break down that radical. But 17's prime, I can't break it down, so I am done. Just remember, you have to type each one separately. Okay? Again, solve for x by using the quadratic formula. Well, a would be 1, b would be -4, c would be 8. My quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. I hope you have this memorized by now. And again, if you watch me, I just go ahead and make my holes first, then plug in, and then I don't worry about forgetting anything. B is -4, A is 1, C is 8. If I simplify, I have a +4 plus or minus the square root. This is going to be 16. This is going to be -32. So that's going to give me the square root of -16 all over 2. When you simplify that radical, the negative comes out as I, and the square root of 16 is 4. So I have x equals 4 plus or minus 4i all over 2. Well, I can reduce them all by 2, which gives me 2 plus or minus 2i. And again, you have to write them out. Compute the discriminant, then determine the number and type of solutions of the given equation. Your discriminant is just b squared minus 4ac. And in my problem, a is 1, b is -7, c is -5. So if I plug those in, b is -7, a is 1, c is -5, I get 49. This negative times this negative is positive. 4 times 1 times 5 is 20, which gives me 40, 50, 69. That is my discriminant. Because it is positive, there's 2 unequal real solutions. Again, when b squared minus 4ac is positive, 2 real solutions. When b squared minus 4ac is exactly 0, 1 real solution. When b squared minus 4ac is negative, then there is no reals. There'll be 2 imaginary. Okay? Compute the discriminant, then determine the number and type of solutions of the given example. B squared minus 4AC. My B is, my B is -2. My A is 7, and my C is 8. So I'm going to have 4 minus, there's only one negative, so that's going to be minus 4 times 7 times 8 is 224, which gives me -220. That's my discriminant. And because it's negative, it means there's going to be 2 imaginary solutions. Okay, compute the discriminant. That's b squared minus 4ac. B in this case is -10. A is 1 and C is 25. That's going to give me 100 One negative is going to be negative. 4 times 1 times 25 is 100, which gives me 0. When my discriminant is exactly 0, then there's only one real solution. Alright, determine the x-intercepts of the graph of the quadratic, then match the function with its graph. When they ask you for x-intercepts, they're asking you to solve the quadratic. That means factor, quadratic formula, whatever you like. I'm going to do factoring. It should be easy because a is 1. Excuse me. X and x make x squared. 5 and 1 make 4 if I subtract. C is negative, which means just the bully gets the middle. So bully 5 is going to get the negative in the middle, and 1's going to be the positive. And now to solve it, you set them to 0. X minus 5 equals 0. X plus 1 equals 0. Add 5, x equals 5. Minus 1, x equals negative 1. So the x-intercepts are at negative 1 and 5. And if you look for the graph that has that vertex, negative 1, 5. Oh no, that's not the vertex, I'm sorry. These x-intercepts, negative 1 is right there, 5 is right there. That has the right x-intercepts, the rest of them don't, so it's got to be t. Okay, suppose the graph of a function is known. The graph of y equals g of x plus 2 may be obtained by a blank shift of the graph of g blank a distance of 2 units. Alright, anything outside is vertical. Anything. If it's outside, your first word is vertical. And if it's outside and adding, that means that it's going to go up. If it's on the inside, it's going to start with horizontal. If it's adding or subtracting, it's a shift. But remember, now this one is going to be backwards because it's with your crazy x. So it's not going to go to the left, it's going to go to the right. Use this graph to graph the function g of x equals f of x plus 3 plus 3. Well, what you do here is you see how they've pointed out some points for you? You're going to get those ordered pairs. This one is going to be negative 4, 0. This ordered pair would be negative 2, negative 2. This ordered pair would be 2, 2. And this ordered pair would be 4, 0. And then you do what we did when we did our transformations. You look at what the problem tells me to do, and if it's to x, you do the opposite, and if it's to y, you do it. This says subtract 3 from all the x's, and this says add 3 to all the y's. If you're doing one thing to do two different letters, the order is not going to matter. But if you have two things to do to the same letter, then order matters. I just am a creature of habit and like to do my x's first. So I'm going to subtract 3 from my x's. That's going to give me negative 7, 0, negative 5, negative 2, negative 1, 2, and 1, 0. And that's done. Now I need to add 3 to my y's. So add 3, add 3, add 3, add 3. I get negative 7, 3, negative 5, 1, negative 1, 5, 1, 3. And that's done, which means I can graph and find which one matches it. So if I plot those ordered pairs, I have negative 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. Negative 1, 2, 3, 4, 5, 1. Negative 1, 5. And 1, 3. And if I know I'm supposed to make the same picture, connect them, and there's your graph. Yeah? And I did expect it to go 3 left and 3 up. Alright. Okay, this one, they've got a multiplier on the outside, which means multiply all of your y's by whatever that number is. So in this case, it's going to be 2. So they gave me the ordered pairs, nice of them, negative 6, 0, negative 2, negative 1, 0, 0, 2, 1, 6, 0. And all this says, again, is multiply your y's by 2. So times 2, times 2, times 2, times 2, times 2, I get negative 6, 0, negative 2, positive 2, 0, 0, 2, 2, 6, negative 2. 6, 0. Sorry. Okay, so now if I plot those points, if I plot negative 2, 2, 0, 0, oops, I forgot negative 6, 0. Negative 6, 0, negative 2, 2, 0, 0, 2, 2, 6, 0, 6, 0, sorry. And if I connect that, oops, that's negative 2. Negative 2, negative 2. Sorry. It comes down, then it comes up, then it comes down. And notice this is going to vertically stretch it by 2, which can you see that, it does. It's much higher and lower now. Okay? This one says multiply the x's by 2, but we never do what we're told with x, so we're going to actually divide my x's by 2. So I have negative 8, 0, negative 2, negative 4, 2, I keep forgetting 0, 0, 2, 4, 8, 0. Again, they're telling me to multiply all my x's by 2's, but I know with my crazy x I got to do everything backwards. So I'm actually going to divide all of my x's by 2. And that's going to give me negative 4, 0, negative 1, negative 4, 0, 0, 1, 4, 4, 0. And if I replot that, I'm going to have negative 4, 0, negative 1, negative 4, 0, 0, 1, 4, and 4, 0. And if I connect, I get that. And can you see that they they horizontally shrunk it. They pushed it in and made it thinner. All right, use transformations of the graph to graph the following, of the mother to graph the following function. What they want you to do on this was get the mother ordered pairs, subtract 4 from all the x's, multiply all the y's by 2, and add 3 to all the y's. And you can do that. And I'll do one. But remember, now that I've taught you the rest of the tricks, could you also graph this just by getting a vertex, an axis of symmetry, and some X intercepts? Yes. All right, but the way we learned to do it in the beginning was we said mother was right here, right? And its ordered pairs were negative 1, 1, 0, 0, 1, 1. And if I do all this math to it, this says subtract 4 from all the x's, so minus 4, minus 4, minus 4. I get negative 5, 1, negative 4, 0, negative 3, 1. Okay, and that's done. Now outside, they want me to multiply by 2 to the y, and they want me to add 3 to my y's. Now since I'm doing more than one thing on the same letter, order matters. And for y, it's multiplication before addition. So I need to multiply all my y's by 2. Negative 5, 2, negative 4, 0, negative 3, 2. Okay, and then I need to add 3. Plus 3, plus 3, plus 3. Negative 5, 5, negative 4, 3, negative 3, 5. And if I plot those points, negative 5, 5, negative 4, 3, negative 3, 5, there's my new parabola. Right? But again, could you have just as easily said, there's my vertex. My vertex is going to be at negative 4, 3. Sure enough, it is. And then you could get your axis, and you could get some X intercepts, which you'd find out there are none, which means you just sketch it up anyway. Alright. Oh, I didn't shrink this one. Alright, use transformations of f of x equals x squared to graph the following function. Again, they're wanting you to do the ordered pairs. But in my mind, that takes a lot of time. I would use what we've just been learning, which is your a, h, and k. A would be negative 4, h would be negative 2, k would be positive 4. So my vertex is going to be at h, comma, k. And if I plot that, negative 2, 1, 2, 3, 4, I know that this, since a is negative 4, I know that it's going to open down. So I'm going to find my x-intercepts. And to find your x-intercepts, you take your function and you set it to 0 and you solve it. Where's my, there it is. So I'm going to minus 4. I'm going to isolate and kill because all I have is a square, so I can isolate and kill it. Minus 4 minus 4. Negative 4, x plus 2 squared equals negative 4. Divide by negative 4, divide by negative 4. I get x plus 2 squared equals 1. Now we're going to square root both sides, and I get x plus 2 equals plus or minus 1. So now when I minus 2, I get x equals negative 2 plus 1, and x equals negative 2 minus 1. This is going to be negative 1, this is going to be negative 3. So I know it crosses the x-axis at negative 1 and at negative 3. And that's enough to graph. Okay? But the ordered pair thing works too. Okay? Give me just a second again. Okay, I'm back. Alright, use transformations of f of x equals the square root of x to graph the following function. I don't know, we did square root functions. Alright, the square root function, to do this one, the square root function mother is right here. Okay, so if we look at this, alright, if I get some ordered pairs for mother, I don't know, let's pick,
Mr. Schaefer, please report to Ms. Campbell's office. Mr. Dennis Schaefer, please report to Ms. Campbell's office.
let's pick negative 2, 0, let's pick negative 4, 0, and 4. And the only reason I'm picking 4s is because I want to pick a perfect square, otherwise it's going to be nasty. Alright, so if I plug in negative 4 for x, I have the square root of negative 4, which is actually plus or minus 2i. It doesn't exist because you can't take the square root of a negative, which is why there's no graph over here on the negative side anyway. If you plug in 0, you get the square root of 0, which is 0. So it's going to pass through 0, 0. And if I take the square root of 4, I'm going to get 2, which is the principal one. So it's going to pass through 1, 2, 3, 4, comma, 2. Alright? And we should have another ordered pair, but we're just going to do 2. So my mother pairs are 0, 0, and 4, 2. That's just 2 points on it. You could use different points. It doesn't have to be this. And then we're going to do the transformations to it. Again, this says go 1 to the right. So this says add 1 to my x's. So that's going to give me 1, 0, and 5, 2. That's done. Outside is multiply and add. I'm going to do PEMDAS order because that's y's. So I'm going to multiply by 3 first on the y's. And that gives me 1, 0, and 5, 6. That's done. And now I'm going to add 5 to my y's. So plus 5 plus 5. That's going to give me 1, 5, and 5, 11. And if I graph that, 1, 2, 3, 4, 5, 6, 7, 1, 5, and 5, 11. 1, 2, 3, 4, 5, all the way up here at 11. This thing is going to do this, which gives me that graph right there. All right. The quadratic function, f of x equals, they're writing in vertex form. They call it standard form, but when they have the a, the x minus h squared, in other words, where you can see the vertex, that's, I call vertex form, they call standard form. The graph is called a parabola, whose vertex is going to be at hk. The graph will open up if a is greater than 1. It will open down if a is less than 0. Greater than 0, less than 0, sorry. Positive a opens up, negative a opens down. Okay, this one says the graph of f of x equals negative 2, x plus 3 squared minus 5 opens down. State whether the statement is true or false. It's true. A is negative 2. Because it's negative, that means it opens down. Alright, the graph of the quadratic function is given. Select the function's equation from the choices given. Well, all I need to write an equation is a, h, and k. Okay? And unless they tell me that I have to find the leading coefficient, they're going to assume that it's 1. So if I can find h and k and plug it in, I got it. Well, h and k is the vertex, which is right there. My vertex is at 4, 4, which means h is 4 and k is 4. So if I plug in 4 there and 4 there, I'll have my function. Y equals x minus 4 squared plus 4. And that's my equation. Okay, in the following exercise, find the coordinates of the vertex for the parabola defined by the given quadratic function. When you are in this form, you can see your vertex because it is at hk. So in this case, h is 9, k is 4, and my vertex is h comma k.
Mr. Schaefer, I have your lesson plans in Ms. Campbell's office.
Sorry about that. Okay, if they want the vertex when it's in what I call standard form, okay, which is ax squared plus bx plus c, you have to get your h by taking the opposite of b over 2a, and your k is c minus ah squared. So in my problem, a is 4, b is 8, c is 8, and I use that to find my h, which would be negative 8 over 2 times 4. That's negative 8 divided by 8, so h equals negative 1. There's the x-coordinate of my vertex. To get k, I'm going to take my c minus my a times my h squared. Negative 1 squared is 1. 1 times 4 is 4. 8 minus 4 is 4, so k equals 4. And there's my vertex. Okay, use the vertex and intercepts to sketch the graph of the quadratic function. Give the equation for the parabola's axis of symmetry. Use the parabola to identify the function's domain and range. Alright, well, my vertex here would be hk, so that's going to be 2, negative 2. Okay, the axis of symmetry is x equals h, which is going to be x equals 2. If I go to plot this, all right, I'm gonna drop the parabola and move the vertex to 2, negative 2, and then you need one other point. You can find intercepts, and if you want to find like this one, I found the y-intercept because it was easier than finding the x-intercepts. If you want a y-intercept to get your second point, find f of 0. That would be 4 times 0 minus 2 squared minus 2. That would be 4 times negative 2 squared. That would be 4 times 4. That'd be 16 minus 2, which is 14. F of 0 equals 14, which means this thing passes through 0, comma 14. So I moved the mouse until I was on that point, and I got my parabola. Your domain, you can't block it left to right, so my domain is negative infinity to infinity. The range, if I block it from bottom to top, the range doesn't even start until starts right there at negative 2 and goes forever up. So it starts at negative 2 and goes to infinity. Okay, use the vertex and intercepts to sketch the graph of the quadratic function. Give the equation of the parabola's axis of symmetry. Use the parabola to find the function's domain and range. Same thing, it's just that I'm going to have to find my own h and k. So h is going to be negative b over 2 times a, which is negative 12 over 2. So h equals negative 6. My k is going to be my c minus my a times my h squared. That's going to be 36 times 1 is 36. 6 minus 36 is negative 30. So my vertex is going to be at negative 6, negative 30. The axis of symmetry is x equals h, so it's x equals negative 6. And if I choose the right graph, the only one that has the right vertex is negative 6, negative 30. This one, I can't even tell. You'd have to enlarge the graphs, but you're going to look for the one that's got the right vertex. Domain, I can't block it left to right, so negative infinity to infinity. Range, there's the bottom of it, which is at the lowest point, which is at the y value. Negative 30 it starts, and it goes on through up to infinity. Alright, an athlete whose event is the shot put releases a shot. When the shot whose path is shown by the graph to the right is released at an angle of 30 degrees, its height in feet can be modeled by this function, where x is the shot's horizontal distance in feet from its point of release. Use this model to solve parts A through C and verify your answers using graphs. What is the maximum height? Anytime they ask you for a maximum, they're asking you for a vertex. To find a vertex, I need h and k. Well, my function is negative 0.01x squared plus 0.6x plus 6.2. So my a is negative 0.01, my b is 0.6, and my c is 6.2. So my h is negative b over 2 times a. That is going to give me negative 0.6, not 0.06, right? Divided by 2 times negative 0.01. And I get 30. So h equals 30. To get my k, I'm going to take my c minus my a times my h squared. That's going to be 900. Negative 0.01 times 900 is going to be negative 9. 6.2 minus a negative 9 turns positive, and that'll give me 15.2. So my maximum height, or my vertex, is at 30, 15.2. That's this point right here. That's the highest point. So the maximum height, again, that's the y-coordinate, and it occurs x feet from the point of release. It says, what is the shot's maximum horizontal distance to the nearest tenth of a foot, or the distance of the throw? They're asking you for this x-intercept right there, which means you need to solve this. So I would have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So let me do this here. 0.6 squared minus 4 times negative 0.01 times 6.2 is 0.608. This is going to be negative 0.6 plus or minus the square root of 0.608 is 0.7797 all over negative 0.02. So if I do the math, I'm going to have negative 0.6 plus 0.7797 enter divided by negative 0.02, and I get negative 8.985, which makes no sense because you can't have negative distances. So if I do my other one, negative 0.6 minus 0.7797 divided by negative 0.02, I get x equals 68.985. And if I round to the nearest 10, the 8 would bump that up to a 0, which bumps that up to a 9, which bumps that at 69.0. Okay, and it says, from what height was the shot released? Well, what shot? From what height was the shot released? So you're looking for the y-intercept. Okay, you're looking for the y-intercept, which in a function where there's no parentheses is your c. So my y-intercept is 6.2. Alright. Find the standard form of the equation of the parabola satisfying the given conditions. It says the focus is 6, 5. The directrix is x equals 4. When your directrix starts with x equals, I know I'm in the y squared function. Okay, so I use these notes. If they give me my focus, they're giving me my h plus p comma k. They're telling me that h plus p equals 6 and that k equals 5. Okay? And the fact that it tells me my directrix is x equals 4, if I look at my directrix tells me x equals h minus p. So I also know that h minus p has to equal negative 4. Okay, just like h plus p had to equal 6, h minus p has to equal negative 4. So now I have this system of equations over here where the p's will always cancel out, which gives me 2h equals 2, divide by 2, and h equals 1. If I substitute that in to either one of the original equations, I can solve for p. So if I substitute it there, I have 1 plus p equals 6, minus 1 minus 1, p equals 5. Okay? So p equals 5. Alright? And now to plug it in, you plug in your h here in your equation, y equals a parenthesis, for this form you have this, so you have y minus k squared equals 4p parentheses x minus h. Again, I needed to find h, k, and p, which I did, so when I plug them in, I'm going to have y minus k, which in my case is 5, squared equals, if p is 5, then 4 times p is 4 times 5, which is 20. So that goes where 4p is. And then I have x minus my h, which is 1. There's my equation. Alright, same thing, but now we're dealing with the x squared equation. There's your focus and your directrix. So for my focus, it's negative 1, 6, which tells me what h and k plus p are. So this tells me that h equals negative 1 and that k plus p equals 6. The directrix tells me, Directrix is y equals 2. That equation is the same as y equals k minus p. So what this tells me is that k minus p has to equal 2. If I line these two up, k plus p equals 6, k minus p equals 2. The p's will cancel. I have 2k equals 8. Divide by 2. K equals 4. Okay, so now I know my k, I know my h, and I got to find my p. Well, now that I know k, I can substitute it into either one of these original equations and find p. So if I go up here, I'm going to do 4 plus p equals 6 minus 4, p equals 2, which means 4p equals 4 times 2, which equals 8. So now in my equation, x minus h squared equals 4p y minus k. I plug in my x, my h, and my p, and I get x minus a negative 1 squared equals 4p was 8, y minus 4. This double negative turns positive, which is where they got the plus instead of the minus. Okay? Find the vertex, focus, and directrix, and I'm going to pause for just a second. Alright, and we're back. So, find the vertex, focus, and directrix of a parabola with a given equation. We are obviously in the y squared, so remember your equation is y minus k squared equals 4p times x minus h. If you can locate, there's your k, that's 4p, and there's your h. So my vertex is going to be at h comma k. So in my problem, that tells me that k equals negative 1. That tells me that 4p equals 16. And that tells me that h equals not negative 5, but positive 5. Same way with not positive 1, because it's in parentheses, it's backwards. So if the vertex is going to be h comma k, which is 5, negative 1. The focus, your focus is h plus p comma k. So if I want to figure out what p is, divide by 4, and p equals 4. So to get my focus, I take my h, which is 5, I add my p, which is 4, and I keep my k, which is negative 1, which gives me 9 comma negative 1. And the directrix of the parabola, for your directrix, you write x equals h minus p. My h is 5, my p is 4, 5 minus 4 is 1, so my equation is x equals 1. And again, pay attention to what they're asking you to type. An ordered pair, an equation, whatever. Alright, same thing, but now x is squared, so we're using the x minus h squared equals 4p y minus k. Again, find your h, your 4p, and your k. There's my h, there's my 4p, there's my k. So in my problem, this tells me that h equals 2. This tells me, this tells me that 4p equals negative 4, and this tells me that k equals positive 1. So p equals negative 1. If you know these three things, you can answer all of the questions. So my focus is at h comma k plus p. So if I put in my h is 2, my k is 1, my p is negative 1, I get 2 comma 0 for my focus. Directrix says y equals k minus p. So I plug in my k minus my p, double negative turns positive, and I get y equals 2 is my equation for my directrix. Oh, and we have to graph these. Sorry, I didn't do that on the other one. So what you would do is you would pick up your parabola and you would place it at your vertex, yes? And then for me, you can't graph your focus, but my focus is going to be at 2, 0, and my directrix is going to be at 2. Ugh. Okay, at 2. And remember, our lattice, you need 2 other points, or 1 other point to graph it on Math Excel. So if we find our lattice rectum is the absolute value of 4p, which is going to be the absolute value of -4, which is 4. Cut that in half, and I want to go 2 units this way and 2 units this way. But for Math Excel, you'll only have to put 1 dot. So put a dot on your vertex and then either one of these points, and it will draw it for you. Let me back up on the Y one. I didn't realize we had to graph it. Okay, so again, over here, you'd go to your vertex, 5, -1, right there. My focus is at 9, -1. So if I can get my lattice rectum, I can either plot that point or that point. My lattice rectum is going to be the absolute value of 4p, which is 16. Absolute value of 16 is 16. Cut it in half is 8. So I need to go 8 points up. 1, 2, 3, 4, 5, 6, 7, 8. Mark it, and the computer will draw the parabola for you. Alright, so solve the following system by the substitution method. Substitution, you line them up sideways. You pick a letter and get it alone. Merry Christmas, happy birthday to me. That one's already alone, so I'm going to cross over and substitute. So I have x plus y equals 1, but I'm going to substitute x squared minus 11 in it. So if I distribute, I get x plus x squared minus 11 equals 1. Put it in the right order, I have x squared plus x minus 11 equals 1. If I solve this, I gotta get 0 on one side, so I'm going to minus 1 minus 1. I have x squared plus x minus 12 equals 0. I'm going to factor. It should be an easy factor since a is 1, so x and x. Factors of 12 that make 1 would be 3 and 4. C is negative, so only bully gets the middle. This one doesn't. Set them to 0 and solve. Add 3. Add 3. Sorry. I'm out of room here. Let me come back up here. Add 3. Add 3. I get x equals 3. Minus 4, x equals -4. So I have 2 ordered pairs, one with an x-coordinate of 3, one with an x-coordinate of -4. I've got to get both y-coordinates, so I'm going to have to go over and substitute both of these in. So I'm going to have y equals x squared minus 11 and y equals x squared minus 11. I'm going to plug in 3 to 1 and -4 the second time. That's going to be 9 minus 11, which is -2. That's going to be 16 minus 11, which is 5. And that's where they got their 2 ordered pairs. Okay? This one they want us to use the addition method, which means multiply the top by the bottom and the bottom by the top. So I have 4x squared minus 5y squared equals -16. 5x squared plus 2y squared equals 13. I'm going to kill the y's, which means I'm going to multiply the top by 2 and the bottom by -5. Since they came out different, I need to make them the same. So I'm going to make them both positive. So distribute. So I'm going to distribute. I'm going to get 8x squared minus 10y squared equals -32. On bottom, I'm going to have 25x squared plus 10y squared equals 65. And now when I combine like terms, the y squareds cancel. I get 33x squared equals 33. Divide by 33. I get x squared equals 1. Square root, I get x equals plus or minus 1. So right now I have two ordered pairs, one with a positive 1, one with a negative 1. So I'm going to have to substitute both of those into one of the originals to get the y coordinates. I'm going to go to this one. So if I plug in 1, I have 5 times 1 squared plus 2y squared equals 13. And then I'm going to have to plug in the negative 1. 5 times negative 1 squared plus 2y squared equals 13. 1 squared is 1, that's 5, plus 2y squared equals 13, minus 5, 2y squared equals 8, divide by 2, y squared equals 4, square root, and I get y equals plus or minus 2, which gives me a problem because when I plug in positive 1, I actually got two different y's, which means I'm going to have 1 and positive 2, and the other one's going to be 1 and negative 2. If I solve this one, negative 1 squared is positive 1 times 5 is 5, plus 2y squared equals 13, minus 5, 2y squared equals 8, divide by 2, y squared equals 4, square root, y equals plus or minus 2. Which again causes a problem. This is going to be two different ordered pairs, both with negative 1 for x, but now one of them gets a positive 2 and one of them gets a negative 2, which is why there are 4 intersection points. Okay? And we are done. So happy homeworking and reviewing, and get ready for your test.